Hey guys, welcome to this new series of tutorials. I'm Jose, and in this series we will be looking at the Plethora library, which is something that I started writing maybe a year ago, which is a set of tools to actually work with agent-based systems and some steering behaviors, but in a way call some of the functionality quicker. So we're going to look a little bit at that. I'll probably have to start just by going to the Plethora library website, right? So if you go to the website plethora.com and then you just go to the library here, you can basically download the library, right? Just click here, you'll see that you can download the zip format here, and you have the reference here, which is going to be quite important. I'm going to just open that as well. So you see that we'll be dealing with the Plethora agent class that has all these methods, and I think they're pretty well documented, and also I've done a few kind of examples of how to use it, and I'm gonna try to do a newer version of the library soon, so just feel free to send some feedback. Also, you have the source code, so everything is open source. If you're interested in looking into the code, it's quite straightforward. It's stuff that you can find both in like Carsten Smith's website and Daniel Shipman's website, but in a way it's trying to kind of bring together different functions and different functionality that allows for behavior in a quite straightforward way. So in a way it becomes a toolbox for behaviors of steering agents, and then how to create trails and all sorts of geometry out of those. So if you look at the source, the way of looking into the source code, just go here, browse, and you can start just navigating through there, right? If you want to do a copy of the repository, you can use Eclipse for doing so. Maybe I'll do a video of how to actually do that, not with mine, but maybe some other kind of library out there. So just for you to know the documentation, everything could be fine. And these are some of the examples that come when you install the library. So let's go into file examples. You'll see that you have here under contributed libraries the Plethora library, right? And you have some of the examples. Some of the examples here, let's say create something like flocking, right? You can just run it and you should have a simple flocking behavior. And some of the graphics involved in this flocking could be done quite easily, and we'll see that. The only important thing to know is that if you go through this library, you see here I'm importing both Toxiclips and PCCam, right? So these examples might not run unless you go into Toxiclips. So you need Toxiclips installed. It's like the Plethora library extends Toxiclips into agent behavior, right? So just download the library of Toxiclips and use, because I'm using those vectors, right? Carsten's vectors library. And also in this case, some of the examples use the PCCam, but that's not somehow, it's not a dependency, right? Like it's just, you can actually remove that. You can work with the Plethora library just with a normal camera, and that should work fine. Actually, there's a camera in the library that allows you to kind of make a motion path, right? So you can just use some of the examples of the camera, but I'm just going to go through some of the content. So let's see how to implement the library from the very basic and see how it works, right? So as I said, you have to import, if we're going to start working with it, we have to import toxi.geom. That's to bring all the vector library, and import plethora.core. Right? So void setup and void draw. The basics of processing. So I mean, I would really recommend you to go through some of the tutorials of my website before going through this one, because I'm going to assume that Lots of the stuff that we're going to be seeing here are kind of already known. For instance, OpenGL, we will need to import the library of OpenGL, right? I think this is native now in 2.0. Yeah, that's true. I'm working with processing 2.0 beta version, so I think that OpenGL is native now. Right, so we could still use import PC. So in a way, these tutorials are going to be a little bit more like a project approach, just dealing with some agent-based systems and how to kind of use some of the functionality of the class, of the library, sorry. So we're going to mix PCCam and a few libraries to actually get these kind of 3D spaces to work. I'm kind of calling the instance of the camera, and initializing the camera, right? Camera equals new PCCam. Please go 100. And let's do a background. So background 235. So here we go. And if we want to see a stroke, I'm gonna do a box just without any boundaries. I mean, without any fill, just to have a kind of a reference rectangle, right? So, and no fill. So we should be fine there. Let's see. Yeah. So we are using the PCCam to create a 3D space. There's nothing about the library here, right? So, but just a simple 3D setup. So let's produce something out of the library. So let's create an agent, right? We're going to use pli_agent, which is the class for Plethora agent. Again, if you don't know where to find these classes, just refer to the documentation file. And you see that there's not too many classes, really. It's just the Plethora agent, the camera, image, node, terrain, tile, utilities. And that's for now. I mean, I'm thinking of implementing more classes, but I just want to document well the ones that I'm writing. So Plethora agent, we're going to call it Bob. So Bob the agent. So that's declaration of the agent, and then Bob equals new Plethora _ agent. And we have to give in the constructor an instance of the processing sketch and a vector, right? So I'm going to just use v as a vector. So we need a vector that is a vector 3D vector. This is going to be the location where the agent is going to start, right? So new vec3d 01010, that could be summarized into empty bracket, just right. So empty bracket means 000 in 3D vector space. So that's a good, like the constructor of the agent. In a way, I tried to keep it as simple as possible, in the sense that you could still like initialize lots of variables through functions, right? Many of those variables don't get really activated unless you explicitly say so. So let's see. Now that we have one version of Bob, so we could say Bob.display point, and that should work. So stroke 255 0, and then stroke weight 5, maybe something like that. And let's see what we get. We have Bob there. And the stroke weight has been applied also for the thickness of the box, which actually makes it look nicer, but maybe it's too thick. So I'm gonna just put here maybe 2. That looks better, right? So we have Bob there, and Bob is an agent. Basically, an agent, as we are understanding it, is just it's just a vector that has a velocity and an acceleration, and basically can perform calculations for flocking and things like that. But also the Plethora class, I mean library, it's in a way written so it relates to a terrain class, which is kind of a projection into a grid, right? And it can perform calculations like stick merge and things like that in relation to the base grid, right? If you're more interested in what the Plethora library can do, again, in the website we did a workshop with it called the Agentware Workshop, and we've been doing several other workshops in Vienna and now in London using some of this content. So it has been developed in the work with students, and in a way whatever new functionality we add to it, it appears in the library, right? So let's do something like simple function like bob.addForce. So 1,0,0, just some force in the x direction, and then we could say bob.update. So update will actually make Bob move, right? So the agent will kind of be displaced, and you're pushing that particle to the side, right? Particle, agent, depending on the kind of forces and the information that you're using, it would behave in different ways. So because I'm using an add force field, I'm calling it a particle, but if you would use something like flocking or steering, right, you could perhaps use the idea of an agent or an autonomous agent, right? So sorry about that. So let's use some of the other functions. So bob.display direction. So display direction would actually show us a little kind of representation of where Bob is moving, right? So we're gonna use 1. Right, we could use 30 there. So you can see that now Bob has a little kind of arrow, right? So, but add force and direction, it seems to be quite boring, so we can actually comment this out. So in a way, all the functions of the library, in a way, you're building a stack of behavior just by combining them, right? So bob.wander 2D, which is it's taken from some of the shipment examples on Craig Reynolds. We could say something like 80, 50, 1. And in a way, we have wander. So you can see that our agent Bob is actually moving around, right? But it gets out of the box, right? So in a way, it's also very simple for the library to kind of have some sort of boundary condition, right? So you could say bob.wrap space 300, 300, 300, and that should produce a, yeah, right? So this is the wrap space, or this kind of boundary condition would make this kind of Pac-Man space where the agent would disappear and appear on the other side, right? So you have another version of that, which is the bound space. So let's look at that. So let's say bound space, and this is the boundaries starting from 0, 0, negative and positive, right? It will go -300 and +300 to define this the boundary condition, right? And if you see here, yeah, right, you get a bouncing behavior with the edges of the, but this behavior is actually being completely 2D, right? So so it's a bit boring still. You could add some 3D behavior just by mixing them up, right? So you could say just move a little bit up while you as you're kind of creating. We got a little bit of craziness there, so just move slightly up. Well, it seems that it gets overwritten. Just the behavior of moving up is so strong that slowly starts just really pointing up, and eventually it's like a negative gravity. And you see that the agent is completely 3D. You can actually work in 3D. So we're gonna leave this off for now. We're gonna use something, for instance, bob.drop trail And drop trail would actually start dropping basically a series of vectors into a list that could represent the past position wherever Bob has been, right? And the first variable here to input is like every, like, do we want to do it every frame or every other frame? So if we put 1, it would be every frame. If we put 5, it would be every 5 frames, right? And then the maximum number of trail points that we want to use. Let's say something like 1,000, right? So nothing happens. We need to not only drop the trail, but we actually need to draw the trail. So let's say Bob dot draw trail, and here we have to do a threshold. We could say something like 15. It's in the case that Bob disappears and appears on the other side of the screen, and the distance between the points of creation is bigger than 50, it won't do the line, right? So you can see that now Bob is actually drawing its path, and it's still bouncing around in the corners of this box, and it's creating this line. And you can see that this line is just yeah, it's just the polyline of the connected dots, right? So it seems that this draw trail could use a little bit of, let's use a smaller line thickness, right? So we have something a bit more subtle. Yeah, so this is all good. What we're gonna do now is just quickly show, like, this is one agent, right? So I mean, you see how you start kind of prototyping behavior with these functions, right? I'm gonna finish this tutorial just by replacing this idea of one only agent with a list. So array list many Bobs. I'm just being silly about the names here, but just serves the purpose. I don't know what's going on with my computer. So I'm going to remove Bob as a global variable, and I'm going to introduce many Bobs. Here I'm going to initialize the array list, so many Bobs equals new array list. And then we have to just initialize the population. So for integer I equals 0, I smaller than 100, I plus plus, and we want to use nice Java flags to actually to implement. So we're going to say Plethora agent like that. So now our array list knows that we're using it's a list of Plethora agents, right? Sorry, I think this is not the right place where it should go, right? And now Bob doesn't exist. So I'm modifying the system just to be able to kind of deal with so all this stuff now should go inside the loop, right? So we describe a vector in 0. Bob, it's going to be a new agent of that class, and we're going to say many Bobs dot add Bob, right? So in this way we're creating many instances of the agent, the Plethora agent, and we're calling it Bob, and we are adding it to the list. Now we have to do all this stuff here for each one of the Bobs. So we're gonna do a for loop that it goes like for pl underscore agent Bob in many Bobs. So you can see now that what we're doing here is just creating 100 Bobs starting on 0 and just branching out, right? If you want to just do a trail that is shorter, we could say, you know, maybe 10 frames only. So we can see what happens, only 10 frames, right? And we do a little drawing. Or you can say maybe 50. Maybe 50 was too much. Maybe 30. So with this we will conclude the first tutorial on the Plethora library. We're going to be showing some additional behaviors, and then how to implement with inheritance, how to extend the library, and how to start doing your own custom agents, and just in a way kind of extend the functionality of the library. But yeah, the only thing is that we're using this kind of for loop, that it's basically looping through every entity inside many bobs. If you're not used to this syntax, it's different from the one I've been using in the tutorials. So thanks to Cornel that sent some links to update this code. And yeah, it should be fairly straightforward. Again, these models should be in the examples file, and if you have any questions, just refer to the scripting references inside the library. So that's it, guys. See you soon.